Okay, here we are. This is Unit 4. This is the first video over polar coordinates. You can see the objectives on this screen. Polar coordinates were developed by James Bernoulli, that's how you say that name, 1691, although they think probably Isaac Newton did. Didn't he do everything? Here are the objectives, and I'm going to follow those objectives pretty closely on this video. On we go. Remember the SOHCAHTOA and the Pythagorean theorem. Not going to spend much time on this, but these are things you should have remembered from geometry, and we're going to use them in terms of polar coordinates. Okay, to introduce polar coordinates, we're going to start with a circle. The circle will be centered at 0, 0 on the Cartesian coordinate plane, the rectangular plane. And you can see that the radius of this circle is r, and the direction from the x-axis is in theta. And then a point on the circle has rectangular coordinates of x, y, so over x and up y. So this particular point that we're talking about here has rectangular coordinates x, y, and they call these rectangular. There's another way to graph this point using angles, and these are polar coordinates. Polar, like the ice caps. Polar coordinates are the length of the radius of the circle, and the second coordinate is theta, or the angle from 0. And this is 0 radians or 0 degrees, but starting there. So in other words, it would be going r units in the theta direction. And that's what polar coordinates are about. And doesn't that sound a little bit like a vector? Because it's true, it has magnitude and direction. Here's your magnitude, here's your direction. So polar coordinates. All right, so let's talk about some of the things we know from a right triangle. We know that this is x, and we know that this is y, and this is a right triangle. So we could write down one relationship that x squared plus y squared is equal to r squared. So you'll notice that the rectangular coordinates have x and y, polar coordinates have r and theta. And if you look at this Pythagorean theorem, you have x squared y squared on one side, r squared on the other. Okay? Another relationship that they have here are the sine, cosine, and tangent relationships. So for instance, the tangent of theta is going to be y over x. And so that's something that we could use. It has theta in it, so we could use the x and the y to find theta. So we're going to put this in our toolkit. And a toolkit is going to be something that we're going to use for conversion, so we're just coming up with those right now. The other two, of course, are sine and cosine. So if I have sine theta is going to be y over r, or I could multiply, y is going to be r sine theta. And you can see that you have rectangular coordinate on this side, and polar r and theta on the right side. So I'm going to write that in here. I'm going to write it y equals r sine theta. I'm trying to keep rectangular on one side, polar on the other. And then, of course, the last one is cosine, and that's x over r. And so x is equal to r cosine theta. So x is equal to r cosine theta. Okay, that's our toolkit, and that's how we would introduce that. All right, so now that we've talked about the unit circle, I want to introduce the actual polar graph. You can see here that the center is at 0, 0. You can see that it has an axis, right? This is the x-axis. This is the y-axis, okay? And then you can see that it would be a circle with various concentric circles. This circle with a radius of 1, 2, 3, 4, 5, 6 out from the center. The center is 0. So if I'm going to graph a point on the polar coordinate plane, then I have them in this form, r theta. You graph them backwards. So you're going to graph the theta first and then the r. So if I had a point, say 2 and pi over 2, then I'm going to go to the pi over 2, and I'm going to go out from the center too, and that graphs the point. But it looks a little different, but if you will realize that a coordinate plane, Cartesian coordinate plane with rectangular coordinates, is the same laid right on top of a polar graph, then you can see that this point right here, 2 pi over 2 in polar, is the same thing as 0, 2 in rectangular. And that's how this works. So, in another way, if I had a point that was -7, or excuse me, -2 pi over 4, we would graph this point in the same way. We would find theta first, so I would go to pi over 4. This is pi over 4. Only instead of going towards the angle, because it's positive, I'm going to go away from the angle 2. So this point right here, -2 pi over 4, could actually be expressed a different way. And that's what we're going to talk about on the next screen, is how can you name a point in more than one way using polar coordinates. All right, we have the polar coordinate plane and we have a point on that plane, and the point is 9 pi over 3. So if we look at this, this is our x-axis, this is our y-axis. So we would find pi over 3, which is out here, and we would go, this is the pi over 3 right here, first quadrant, and then I would go out 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, which is approximately here. All right, so this angle right here is pi over 3. Well, all the way around a circle is going to be, in thirds, is going to be 6 pi over 3. All right, so I want to name it another way. Well, one way to do that is to, instead of having the positive angle, the other thing we want to do is keep it between -2 pi and 2 pi. So we don't want to add 360 or add 2 pi, and we're not doing revolutions. We're going to keep it within 2 pi. So here's a way to do that. This next one, I'm going to come around this way. So that's going to be 6 pi over 3 minus pi over 3, which is 5 pi over 3, but it's in the negative direction. Another way to name this is to extend this pi over 3 into this quadrant, right? And so this one right here, if I go in the positive way, is going to be 3 pi over 3 plus another, so this is 4 pi over 3. Right? But I don't want to go out 9 here. I want to go back 9 this way. So this is going to be 4 pi over 3, but I'm going to go in the negative direction. The last point will be just to rename this using a negative. And so going back this way, I would have, this is 3 pi over 3 less a third, so that would be -2 pi over 3. So we're still using coterminal angles. We're finding them a little bit differently than we did before in class. But I want you to look at these when we do them in class and see if you can find a pattern. It'll make it a little easier. Okay, the last thing we want to do is we want to learn how to convert from polar coordinates to rectangular coordinates. And our example is 4, 5 pi over 6, and that's written in polar coordinates. And I want to convert that to rectangular. So I'm just going to draw a quick sketch to kind of give me an idea of where that is. So here's 5 pi over 6, and I'm going to go out 4. All right, so I'm making note that this is in the second quadrant, where cosine is negative and sine is positive. This is cosine, this is sine, second quadrant. So when I write my rectangular coordinates, I know that the x is going to be negative and the y is going to be positive. That's what I want to end up with. Now, because 5 pi over 6 is on my unit circle, this needs to be exact, so no calculator. All right, so in order to find x, I'm going to use my toolkit. It's going to be r cosine theta is going to get me x. Well, r is 4 cosine 5 pi over 6. All right, now I already know that the first coordinate is going to be negative because cosine is negative in the second quadrant. So now I'm just going to think first quadrant values. What is the cosine of pi over 6? Well, that's going to be square root of 3 over 2. That reduces, right? A 2 goes into 4 2 times. So I end up with 2 square root of 3, and it's negative. The y-coordinate is r sine theta. R is still 4. Theta is 5 pi over 6. Well, if cosine of pi over 6 is square root of 3 over 2, then the sine is going to be 1/2. So this is going to be 4 times 1/2. 4 divided by 2 is 2. This is a set of coordinates in the second quadrant in the same place as the polar coordinates. So now you've watched this video. If you don't understand part of it, please bring your questions to class very first thing, and then I'll see you in class.